Okay, so this unit is transformations. And after you get the first quiz back and you go, how did I do so awful? And actually what you'll be doing is 2 quizzes down the road, you'll be looking back at your first quiz and saying, how did I do so awful? Like, this stuff is so easy. Okay? And really, it is, but you got to be paying attention to what we're doing. You got to read the question. Carefully think about, what is it asking? What are they giving me? What do I have to find out? What do I know? What am I looking for? Okay, reflection. So I asked you to do the first part of this, so we'll just go through and summarize. Comparing the graph of y equals f of x and negative y equals f of x. A function is given by y equals f of x. Now this is general function, this is specific. X plus 2, quantity squared plus 1. It's something we can graph. The equation that represents negative y. So what we're doing is, what happens when I replace a y with a negative y? Right? What have we done? What happens when I replace y with y plus 4? What happens when I replace x with x minus 3? That was the translations. Okay, now we're into reflection. So negative y equals fx. I'm replacing y with negative y. This becomes negative y. This stays the same. We can't graph negative y in our calculator, though. So what are we going to graph? Y equals what? Negative x plus 2 quantity squared minus 1. Okay, so we're going to take that negative from the left side, we're going to distribute it through the right side, turning each expression negative. So the negative of x plus 2 quantity squared, and not plus 1, but minus 1. On the same graphing calculator screen, you will sketch y equals f of x and y equals negative x. So examine the graphs and complete the following. For y equals f of x, which is x plus 2 quantity squared plus 1, when y was replaced with negative y, the graph of negative y equals f of x is the graph of y equals f of x reflected in the x-axis. So reflected in the x-axis, which is the line y equals 0. Okay? So when y is replaced with negative y, it's a reflection in the x-axis, or instead of x-axis, they may use the line y equals 0, right? Which is the x-axis. Same thing, just different names. The point 110 lies on the graph of blah blah. So the corresponding image point is what? 1, negative 10, right? What are we doing? We're replacing y with negative y. Y was 10, negative y is negative 10. The corresponding image point on xy is x negative y, right? What did we do? Well, the whole thing is I'm replacing y with negative y. So, why, you ask? Negative y, I say. Comparing the graph, okay, so everybody good with that? If y is replaced with negative y, you get negative y equals f of x, which we're never going to write, so you're always going to write as y equals the negative of f of x, which says what? I'll take the y coordinate and make it the negative of what it was, and there we go. Okay, what if we do this? Y equals f of x and y equals f of negative x. So a function is given by y equals f of x. The equation that represents this, represents y equals f of negative x, is what? So what's it? The square root of. Okay, so I see an x, I replace it with negative x. What do I do with the minus 2? It's just along for the ride. Okay, so we are not making what's underneath there negative. We are simply saying where you see an x, you now write a negative x. The minus 2, let's go there, minus 2. On the same graphing calculator. Graphs, I never wrote this in here, but how might you want to write this? So it's negative, it's the negative of what? X plus 2. Okay, I just threw that in there. I don't know if I'll talk about it, but well, when x is replaced by x plus 2, what's going on? It moves 2 to the left. Okay, so its reflection is going 2 to the left. Right? So just think about that. Anyway, examine the graphs, complete the following. For y equals f of x, which is the root of x minus 2, when x is replaced with negative x, the graph of y equals f of negative x is the graph y equals f of x, blank in the blank. So what happened? What did you see when you graphed? It's reflected in the y-axis, or the line x equals 0, right? Which is the equation of the y-axis, right? What's on that line? X is 0. What's y? Anything you want, but x is 0. The point 6,2 lies on the graph. The corresponding image point is? Yeah, because x is replaced, so x is replaced with negative x. The point xy would map to the image point. Right, and again, x is replaced with negative x, right? Okay.
The timeline says quiz on Tuesday, September 16th.
Yes.
Tuesday is actually September 15th.
So is it the 16th?
It's still on Tuesday.
Okay, so the quiz is on Tuesday, but Tuesday is the 15th. That's okay, on the 3-2 timeline, I stuck Labor Day as the day, and they said, hey, we're not thinking. Okay, so the quiz is next Tuesday, which is the 15th, despite your timeline saying that Tuesday is the 16th.
So, a week from today.
It's a week from today. Okay, so we good with the first page, which you did on the weekend and said, hey, look at all this stuff happening. Okay, complete the following table for y equals f of x. If I want to reflect on the x-axis, which is the line y equals 0, then the replacement in the function is what? What do I replace? What do I replace it with? Y with negative y. So what's the new function? Right, because here's the original function, y. So the new function is, or we're more likely going to say what? So when stuff's on the right side, it's just doing what it says it's going to do, right? It's going to make the y value negative, right? The y equals the negative of what it would have been, which is the reflection. Image point of xy. Okay, you can fill in the next line. Or can you? Well, can you fill it in correctly? Checks answer key. Seems to agree. Okay. So we all good? All right, so those are the two reflections. Actually, those are two of the three reflections, but we'll get to the third later. Answer the following question. For f of x is the root of x plus 2 minus 5. Is the equation for the function given in terms of f of x or in terms of x? Can you graph it? So it's in terms of x, right? So what do we know? Well, I can graph the square root of x plus 2 minus 5, which is a square root graph. What's happened to this square root graph? It's been shifted, translated horizontally to the left and vertically down 5. Okay, good. How do you know? So it is in terms of x. And how do we know? Because it is, the function is fully defined and graphable. So the function is fully defined and graphable. Okay, it's not one of those things that, hey, there's a straight line here, and there's another straight line joined up to that, and there's some kind of little curve in the middle. No, it's... The point 14, negative 1 lies on f of x. Complete the mapping for each of the following reflections. Okay, so forget about the fact that it's moved to. It's just, okay, here's this f of x. If I reflect it on the x-axis, where does 14, negative 1 end up? Okay, goes to 14, comma 1. Right? Reflection in the x-axis, it was 1 below. It is now 1 above. If this is reflected on the y-axis, okay, negative 14, negative 1, right? So reflection on the x-axis, y is replaced with negative y, so the y, which is -1, -1 is 1. Reflection on the y-axis, x is replaced with -x. You were 14 units to the right. You're reflecting about this vertical line. You are now 14 units the other side, right, which would be -14. Write the equation of the image of y equals the root of x plus 2 minus 5. After each reflection, express your answers so that y is isolated. Okay, so if we're going to do a reflection in the x-axis, what are we replacing with what? Okay, so where I see y, I write negative y is equal to the root of x plus 2 minus 5. But we don't do that, right? We don't write y plus 3 equals either. We isolate y. So this is y equals what? So the negative of the root of x plus 2 plus 5. When you're writing radical signs, watch your sign, like, don't do this and don't do that. Okay, don't write it like this. Make sure that this extends, and don't write it like this, right? Because that's not right. Okay, so make sure you. I mean, I wouldn't take marks off you unless it was sort of obvious that you didn't even include the plus 2 in there or something, right? So. Yeah, make sure it's close. Reflection in the x-axis, what do we do? Okay, the plus 2 we just leave. Right? Just stays as plus. So all I do is I replace x with negative x. This results in a reflection in the y-axis. Okay, so think about all these transformations. They all follow the same rule. It's not like, oh, but if there's a plus 2 under there, then no. See an x? Replace it with a negative x. Invariant point, a point that is unaltered by a transformation. The graph of y equals g of x is shown to the right. This is not graphable, right? Therefore, it's just g of x. Here's some function g of x, and here's a nice little drawing of it. Complete the table below. Okay, so let's start off by doing the domain and range of the original, function. So what is the domain? I'm going to do set notation. Set of all x such that, okay, what's the domain of the original function? Just say between this and this. -8 and 1. Okay, and go from left to right. So -8 is less than or equal to x is less than or equal to 1. And range, what's the low? -3. High? 6. Okay. So there's now, I don't even need to see what's going on in order to do the reflections and change the domain and range to adjust for that, right? I don't need to see what's up there anymore. Okay. So if I do this, y equals g, so I've replaced x with -x, what's the description? It's a reflection in the y-axis. Okay, now, so what's the new domain? So now I'll go back and look at this. So I'm reflecting it. So where does this point go? It's reflected in the, where do we reflect in? The y-axis. So where does this point go?
Positive 9.
So it stays at -8. It's reflected in, yeah. Okay, so range-wise now we go -6. Now this was the low, where does this go? What are we doing? Oh, sorry, reflection on the y-axis. Okay, so sorry. So this -8 goes to +8. This +1 goes to, so our new domain is from -1 to +8. Okay. And what happens to our range when I reflect in the y-axis? Nothing. Okay, invariant points. So which point will remain the same, or will any of them? So this point we know moves to here. This point goes to positive 5. This point went over to positive 8. Where does this point go? Stays the same. Oh, so if it stays the same, then it was not altered, and so what is the invariant point? 0, negative 3. No. Okay, do the next one. Don't mess it up. Does it ask us to draw them? I think it did. No, I've got one. Okay. So it's okay. There's a skeleton for you. I have a bunch of right numbers, right? Did this. So kind of but it's 38. Change that. That's good. Well, let's put or the line. Okay, so I'm just adding a little bit to the one above. It's a reflection in the y-axis. Let's just write or the line x equals 0. And reflection in this one is the x-axis, or the line y equals 0, right? So when we write reflection in the axis, let's also just keep in mind it's or the line, whatever. So the invariant point is which? Or is there more than one? There are 2 of them, so I should leave some room. Okay, what are the invariant points? Not there yet? Okay, what's the domain? What's the range? Okay, so the domain is the same as the original, right? Because what are we are we changing the x values? Domain is the x values. We're not changing the x values, right? What are we changing? The y values. So this is this. Okay, it's reflected in the x-axis. So where does this point go? This point here. When I reflect it, it ends up where? Same point. What about this point? Same point. Okay, so what are their coordinates? -6, 0, and 1, 0. Okay. Use different colors. Accurately draw the graphs. Okay, so then what I want to do is take this and just say, okay, I'm reflecting, so the +6 becomes -6. This point stays the same. This point goes where? -5 and +3. This point goes where? And this point stays the same. Okay. If the black line was on there and I put a transparency over the black line and copied it, can I get the purple or the red line by just moving things around, like shifting that? So it's the same size, right? Those are exactly the same size. They're the same shapes, right? All that's happened is, what? One is a reflection, so I would just pick up the transparency with the purple and do this with it and maybe slide it over a bit or something, you know, I would actually reflect it along that line, and then here just pick up the transparency, flip it upside down, and I could put it in the right place. So they're congruent shapes. Use different colors. Check. Given the graph of a function, y equals f of x, complete the table. So this time, so what we're really doing is we're looking at the same stuff in many different ways, right? And that's all we do with translations, and that's all we're doing with reflections. We've got the basics. We're now just looking at it in different ways. So if I tell you, hey, starting with y equals f of x, the equation is y equals f of negative x, then what is it reflected about? Okay, it's reflected about the y-axis or the line x equals 0. Now, where are the invariant points? So, if I said, describe to me where the invariant points are, what would you say? They are on, well, they're on x equals 0, which is known as, so they're on the y-axis. If a point's on the y-axis, then we say that it is the y-intercept. Okay, so y-intercept. Or intersects, right, if there's more than one. Okay, you should be able to fill in the next line. Now, if you need to, you can back it up a step, right? Oh, I see y equals negative f of x. That means that this started out as negative y equals f of x, which means that y was replaced with negative y. If that happens, that's a reflection about or the line y equals 0 is the x-axis, the x-axis. So where are the invariant points? They're on the x-axis. What do we call points on the x-axis? So they are the x-intercept or intersects. So in general, with reflections, the invariant points lie on the line of reflection. Okay. So where are the invariant points? They're on the line of reflection, right? Because where are you going to go? You're on that line. You can't go anywhere, right? Like I'm 5 units to the left of the line. I can go 5 units to the right of the line. I'm 5 units above. I can go 5 units below. If I'm on the line, I'm on the line. If you walk up to a mirror and stick your nose on the mirror, that's the invariant point, right? I mean, the rest of the reflections look like they're at a depth equal to however far away they are from, you know, the mirror. They only look that, not really, it doesn't exist in 3 dimensions, right? Algebraically determine the exact values of the coordinates of the invariant point when the function blah 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 is reflected over the. Okay, if it's reflected over the y-axis, then where are the invariant points? On the y-axis. What do we call the points on the y-axis? So we are looking for the y-intercept, right? Now, being as this is a quadratic, we know that it has one y-intercept. Okay. When does the y-intercept occur? What are we looking for? X is equal to 0. Right? What's another name for the y-axis? It's the line x equals 0, right? So we're looking for where x is equal to 0. Okay. So y is equal to 2 times 0 squared plus 6 times 0 minus 3. So y is equal to negative 3. Okay, now it says determine the exact value of the coordinate of the invariant point. What is the coordinate of a point whose y-intercept is negative 3? What's x? 0, comma, negative 3. 0, comma, negative 3. So that is the coordinate, right? Coordinate has to be an x, comma, y, right, in parentheses, the point. X-axis, what's the x-axis? Or sorry, if we're on the x-axis, what are we looking for? The x-intercepts. How do you get the x-intercepts? You set y equal to 0. Why is that? Well, because the equation of the x-axis is y equals 0. So I'm looking for when y is equal to 0. So I'm going to go to this and put y is equal to 0. And then what are we going to do? Well, we're going to solve by factoring, except it doesn't factor. So then we're going to solve by using the quadratic formula, which if sung to the tune of Pop Goes the Weasel, right? Is anybody within 20-1 with me? We sang it to that very tune. Okay, so should be an X on that, right? Okay, so -6 plus or minus the square root of +6 quantity squared minus 4 times 2 times -3. All right, so we just kind of pound through this, right? So it's 36 plus 24 over 4. And that'll make that 40, so let's go with 60. Largest perfect square that goes into 60 is probably 4, right? So we got 6, 2 root 15, 4. Reducing. Come up with that, which amazingly agrees with what I have here. And what are the coordinates? So what are those? Those are the axes, right? Now we take them one at a time. So we take those guys one at a time, make coordinates out of them. So x is, right, there are two possible values for x. There are two x-intercepts. Okay, and they are -3 plus root 15 over 2, comma 0, and -3 minus root 15 over 2, comma 0. If this were numeric response, we could either put like a negative a plus or minus root b over c and ask you to fill those in, or say the product of a, b, and c is, or some silly thing like that. And otherwise, we want exact values, right? Or we could ask round it to the nearest tenth or hundredth. What is the largest value, right? The -3 minus root 15 over 2 is negative, obviously. You can't get a negative numeric response. You can. It will be incorrect, right? So numeric response are always positive. Therefore, if you get a negative, you know you blew it. Go back, see what you did. Okay. Then we would say the largest x-intercept of rounded to the nearest hundredth is, and you plug that in and work it out. Okay, so questions on number 4? Nope. It's all easy, right? Until the quiz, and then it's like, I saw that before. I wish I'd have done 1 or 2 of those to kind of cement my learning, right? As opposed to, it looked easy when you did it. Fill this in. Okay, I'm actually just going to pause this because it's kind of boring. Okay, I'm reflecting about the y-axis. So I am replacing x with negative x. So what's the new domain? Negative b less than or equal to x less than or equal to negative a. Okay, what were the for real numbers we used? They were -8 to +1. And what did they become? Well, the -8 became +8, which means, well, now it's bigger, so it's got to shift. The +1 became -1, so it became -1 less than or equal to x less than or equal to +8. Right? So they will interchange places. Now, what if they were both negative? Just think about it. What if they were both positive? Just think about it, right? Will they end up in the right places if I enter? Yeah, they will. Okay, and then what goes here? And then try, what were the numbers that we used originally, right? Well, they were -3 to +6. Okay, if I entered, well, then what did it change to? It changed to -6 to +3. Is that what happens here? Yeah, negative of the 6, which is now negative 6, and the negative of negative 3, which was positive 3. So it works. Think about that, right? This is this is sort of the key to, yeah, am I getting the right things? If I could do this in general, then I sure can't do it with a specific set of numbers, right? And you just did them with a specific set of numbers earlier, so now you just got to think, how do I generalize this? Okay. Well, reflecting in the y, so the x's get replaced with negative x, that becomes negative a, that becomes negative b, but then wait a sec, they're going to switch. Combining, so, okay, now we've got the whole reflection thing down, right? But the first thing we do is translations. Now we're going to combine the two together, right? We're going to do reflection and then a translation. Or should it be vice versa? Well, let's look. The point 32 lies on the graph of y equals g of x. Some ungraphable graph, right? But there is this point on it. If y equals g of x is reflected in the x-axis and then translated down 1 unit. All right, so I'm of too simple a mind. I must do this in 2 steps. So the point 32 is reflected in the x-axis. What does it become? So 3, 2 becomes 3, negative 2. And then translated down 1, so where is it now? 3, negative 3. So the point 32 becomes 3, negative 3. This is how it became that. And I went through the transformations in order, right? So I did the reflection, and then I moved it down 1. Okay, if y equals g of x is translated down 1 unit, and then, all right, so again, I'm slow, I gotta do this one step at a time. So if I translate it down 1 unit, then 3, 2 becomes 3, 1, and then reflected in the x-axis, becoming 3, negative 1, then 3, 2's image point is 3, negative 1, right? Which we got to in 2 steps, because I'm kind of simple and I need to do each step separate. All right, same transformations were performed, but the image points are not the same, right? It's either 3, negative 3 or it's 3, negative 1. Well, not either. I mean, in one case, it's 3, negative 3, and in the other case, so what can we say about this? Why are the image points not the same? Yeah, so in one we reflected and then we translated, in the other we translated. So the transformations came in a different order. So the order of the transformations was different. Why are they not the same? The order of the transformations was different. Note, order is important, right? Obviously. So we are going to set a standard. Unless stated otherwise, always do the reflections first, then the translation. Okay? So if I give you a reflection, I mean, obviously, right? If I say do the translation and the reflection, I want you to do it in that order. If we don't say anything, you will do reflection first, then you will do a translation. Okay? So if you're looking at, oh, look, here's a new equation, and I'm going to list the transformations, I'm going to do it in, I must do a reflection first, then I will do the translation. Okay? Very important. Okay, the graph of y equals f of x, which is not graphable on a graphing calculator, right? I mean, you can't just plug in an equation. Is shown below. Wow. So complete the table below, so which must be for me on the other page. Okay, so what do we got? Description of transformations, the image point, the domain, and the range. All right, let's start just by filling in the domain and range of the original thing. So what is the domain and range of the original thing? I'm going to do it with set. So the set of all x such that domain, low value, high x value. What? I'm hearing different numbers. 0 to 6. Okay, 0 to 6. Range? -8. 2 minus 1. Right. I don't know if I can trust you guys. I just need to take a quick look. Okay, yeah, that's right. All right. So in order to do this question, very first thing I think you need to do is, in words, describe the transformation. What's going on and what comes first. So looking at this, what's the first thing we want to do? So there is a reflection in the y-axis. Followed by, so what kind of translation? Vertical translation, up 3. Okay, so not a lot of room here, so I am willing to take abbreviations, so VT up 3. I'm willing for you to write the reflection as REFL, reflection in y-axis, VT up 3. Okay, so if I'm doing the image point, so what should we do next? Should we do the image point or the new domain and range? Okay, does it matter? Okay, new image point. Let's do this in 2 steps, right? So let's list the first, right? If we do it in 2 steps, then we should be good. We aren't going to mess up. If we try and do it in 1 step, things are probably going to go bad. So what's the reflection in the y-axis? Yeah, well, x is replaced by negative x, so negative x comma y. And then up 3, what do we get? Okay, so there, I just wrote them beside, right? Reflection in the y-axis, the point xy has become negative xy. Take that up 3. Nice thing about image point things is you just do what you're told to do. Go up 3. Okay, take the y, let's add 3 to it. Okay, so what's the new domain? Now, okay, we could do this in 2 steps as well, but I don't think we have to at this point. I think we can just list them. Because one of these things affected the domain and one of these things affected the range, so it's, it's not like, okay, we did this reflection and then we moved it left 3, so both of those would be acting on the domain. It's like one thing affected the domain. So what's the new domain? Yeah, don't write -0. It's just 0. Is 0 negative or is 0 positive? Neither. The Switzerland of numbers is neutral, right? What's the range? Which way did we go? Up 3. So -8 goes up to -5, and -1 goes up to +2. Okay, so Melchek said, do 2 of these, so let's do the next one. -y plus 1, f of x. So I might want to rewrite this a little bit, right? Yeah, I can see what's going on, but you might also see this like this. Or you really might see this. Okay. So what I can do is multiply both sides by -1, which turns the left side positive, and it becomes y plus 1 is negative f of x. And then isolate the y, so it becomes y is equal to negative. You might not be able to see that from here. You gotta watch when it's negative f of x, especially the way I've written that. It's like the negative blends in with the f. So there almost is a space there. So y equals negative f of x minus 1. You could also have done this. Negative y minus 1 is f of x, right? But you're going to get to the same thing, and I think it's easier to do that. All right, so was there a reflection? What kind of reflection? There's a reflection in the x-axis, and then Vertical translation, down 1. Down 1. See, y was replaced with y plus 1, which we all know is a vertical translation down 1, and then there was this negative that came into being, so that the y plus 1 is replaced with a negative y plus 1, which is reflection in the x-axis. Okay, so fill in the rest. Again, if I'm going to do the image point, I'm going to do it in 2 steps, just because. So the reflection in the x-axis, the y is replaced with a negative y, we get x negative y, and then I want to move that down 1. So from the negative y, I'm going to subtract 1, right? And that'll move it down 1. So to reflect it first, right? So the point that was at like a 2 now goes to negative 2, and then gets moved down 1. So that does it. Okay, now you need to do this. So anyway, how does the domain change? It doesn't. So what was the original? So just 0. So now you figure out what's the new range. If you want, you can do it in 2 steps. Okay? It's not necessarily a bad thing to do it in 2 steps. Just say, okay, what did the range do when I reflected it in the x-axis? And then what did it do? Okay. So it's not bad to just say, it did this, and then it did this. And it's not bad to just say, here's where it ended up. Okay. And then just like box up the final correct one. If you're going to do it in 2 steps, do it in 2 steps, circle or box up the correct one, right? Okay. Or you do it in 1 step. Okay. So I've chosen to do the range in 2 steps. First I reflected it, right? What happens when I reflect? Well, I just take these numbers, reverse them, and change their signs, right? That's all I do. For the reflection, take these numbers, flip them around, change their signs, -6 to 0. So reflection, +1, +8. Then move down 1. From 1, I go down to 0. From 8, I go down to 7. There's my final thing. Okay, so I'm going to hit pause. You do the last one. And then stuff happened. Graphs were graphed. You'll be looking at the answers, and it might seem somewhat magic, but hey, that's what wise time is for. So, okay. Now, yeah, it's still counting up now. We're good. Okay, the graph of y equals g. So different question, right? You got to watch out for, is this like part B of something, so it refers back to what's there? No, new question. The graph of y equals g of x, some ungraphable graph, is reflected about the x-axis and translated 1 unit right, in that order. State the equation of the transformed image in terms of g of x with y isolated. Okay. What the heck does that mean? So, what it means is we are starting with y equals g of x. And we are going to reflect that about the x-axis. So, to reflect about the x-axis, what gets replaced with what? Y is replaced with -y. So now I write -y is equal to g of x. Okay, and now we are going to translate it 1 unit to the right. So -y is equal to g of x minus 1. But it says transform image with y isolated, so we have to get this by itself. So it's y is equal to Okay? If you go there directly, it's like whatever, right? Because it says state. State just means we're giving the answer. I'm not looking at what you did. I don't care. But you know, if you write it out, at least then you can maybe get a half a mark if you messed up. You say, look, I did this right, and then I messed up here. Graph of y equals h of x reflected over the line x equals 0. Oh my god, line x equals 0. You have to figure out what that is. And translated 2 units to the left, state the equation. Okay, you do 9. I'd pause it, but I've got to make up time. Must have at least an hour's worth of video to load. No. That's not true. But you're just doing the same set of steps. So do the same set of steps we just did, only correctly for this h of x thing. See people not writing. It's like, I worked ahead. I already did it.
Negative g, x equals 2. Or 2.g with that.
Okay, so I've taken you to that key moment. The key moment, right? So we are reflecting in the y-axis, right? So everywhere I see x, I'm going to replace it with negative x. Now, hey, key moment. I want to move 2 units left. In order to move 2 units left, what do I do with the x? I replace it with x plus 2. So you see the x? Got a negative sign in front, so here's the negative sign. You see the x? I'm going to now replace it with x plus 2. Now, we're generally not going to write that, so what are we going to write? Okay, so we replace x with negative x. Fine, everywhere I see an x, I now write a negative x. Then what? Okay, I want to translate it 2 units left. Okay, 2 units left, good, easy. That's like so last week. X is replaced by x plus 2. Okay, you see the x? Put it in brackets, replace it with x plus 2. Okay, now what do? Well, you may or may not, but the final step could be, I see negative x minus 2. So here's the deal. On a test, you see this. Y equals h of negative x minus 2. And I ask you what happened, and you say, ha, I must isolate the x, so I got to rewrite it like this. And now I can tell you, this moved left 2. Oh, wait, but I have to do reflection first. So it's reflected in the y-axis, or line x equals 0, and then moved left 2. Okay? So this is what you see, and 50 to 70% of you are going to say, right 2. And I say, wrong, 0. Okay? So you got to isolate. Okay. Yes. Four?
You know you said you had to isolate. What is this for?
That's fine, you might see that. You might see it written like this, so you have to know. If I see negative x minus 2, then I need to rewrite it like that, so I can read the transformation right off. Either or. Okay, 10. The graphs of y equals f of x and g of x are shown below. I know, it's long. You signed up for it, man. You probably could have just done 3-2. It's like, I want to be a nurse. Well, they really want 3-2 if you want to just be, not just be a nurse. Like, consulting nurses anywhere. Nurses are very valuable. One day you could be one. It's like, hey, there's my old math teacher lying in a bed hooked up to it. I remember what you said about nurses. Nurses are great. Okay, the graphs of y equals f of x and y equals g of x are shown below. If g of x is the transformed image, okay? So we started with this, and this is what we ended with, right? Keep that in mind, which one is which. Generally, we'll go from f to g. That doesn't mean that f won't be on the left and g on the right, right? It just means f is your starting, f of x is your starting, and g of x. Then write the equation of g of x in terms of f of x. And watch how this is done, right? There's a whole step of things you go through, and then there's the final switcheroo at the end, which is kind of the key. Also, write the transformation using mapping notation. All right, so we got to do two things, right? But first, we need to use our words. We need to look at this and see if we can describe in words what's going on here. Okay? So, do they open the same way? It can't be reflected in the x-axis, right? Because then this little V shape would be upside down, yeah? So it's not that. Okay, this kind of has the long end here, but this has the long end here, so there was, number one, reflection on the x-axis. Right, reflection on the y-axis. Okay, if that happened, then let's just take one point. This point here ended up here. But now it has to go one right, and so there's a horizontal translation right 1, and there is a vertical translation down 3. Okay, so everybody get how we figured that out? So we looked at it and we said, okay, obviously it's reflected in the y-axis because it's not a congruent shape, right? But it looks like, oh yeah, okay, that's been reflected. Then I took one of the points. Doesn't matter which one. I could take this point. Okay, reflected. Now it's here. Okay, but it's got to go here and then here. So right 1, down 3. Okay, everybody good with that? Question's almost done then, right? What are you going to write? You're just going to say, well, okay, so I started with y equals f of x, what I started with. I reflected it on the y-axis, so what am I going to write? Y equals f of negative x. Yep. I moved it right 1, so that's y equals f of negative bracket x minus 1, right? Because I got to move, so I have the x minus 1. And I wish I'd left some more room in there. Okay. I'll slide this over. So this is y equals f of negative, the negative from before. Now I replace the x with x minus 1. And I can do the down 3 at the same time. How do I do down 3? Minus 3. Okay, so then what can we write? Y equals f of negative x plus 1 minus 3. Okay, which of those do you have to show? Either one. Well, probably we should go to the last one, right? But it didn't say, it said, then write g of x in terms of f of x. So here's the whole key to that. You write g of x in terms of f of x. There you go. How many people are confused by, well, g of x? It's easy, just write it as y equals, and at the end replace the y with g of x. Boom, done. Okay, so I've written, so g of x is written in terms of f of x, right? It's f of negative x plus 1 minus 3. If you are given this, you are going to translate it to y equals, and then you are going to translate it to here, and then you can read the transformations from this, right? Which is, oh, reflected in the y-axis, right 1, down 3, boom. There they are. Okay, what else did it say? It said, where does xy map? So, xy. Let's see if we can do this in one fell swoop. Reflected on the x-axis means that I'm going to have a negative x, and then I want to move that right 1. So it's going to be negative x reflected, right 1 plus 1. And I want to move down 3, so that's just y minus 3. So the negative of x plus 1. Again, if it helps you, do it in the 3 steps, right? Take xy to negative xy to negative x plus 1y to negative x. Although I do the translations I would do at the same time, just because they're affecting different things, right? It's not like, oh, it's going to change this and then it's going to change this again. Did I pass around the attendance thing? Good. Where is it? Oh my God, somebody gave it to me. Oh, that's right, because they changed the 5th to the 8th because I didn't. It's good, it's good. Good time. Okay. Okay. Doobie. Doobie. Be good. Doobies. Anybody do romper room? Didn't they have doobies or something? No, wait, that's the doobie bro. Never different thing. Never mind.